Okay, so number 15 says if f is a function defined by the following, what are all the x-coordinates of the points of inflection for the graph of f? So I'm going to, because of points of inflection, go ahead and take the second derivative. So f prime of x is equal to 15x to the fourth minus 20x to the third, and then I'm going to take the second derivative. And then I'll get 60x to the third minus 60x squared. Now I'm going to set this equal to 0 and factor out common or GCF, which is 60x squared, and I get x minus 1. So my critical numbers are x is equal to 0 and x is equal to 1. Those are my critical numbers, not necessarily immediately my points of inflection. I do have to check for sign changes. Remember, sign changes occur not only on the first but also the second derivative. The first derivative denoting where my max and mins are relative-wise, and the second derivative denoting where my points of inflection, as long as there are sign changes occurring. Okay, so 0 and 1, and we're going to go ahead and check the signs. So from this factored out form, pick a number less than 0. So if I pick like a negative 1 and I put it here, I'm going to get a negative and then a positive, so this product is a negative. If I pick something like 0.5, so 0.5 minus 1 would give me a negative, and then if I were to put 0.5 here, I would also get a positive, so multiplying that out, I would get still a negative. And then finally looking at the last interval, let's say that would be pick 2. 2 minus 1 is a positive. Remember, it doesn't matter what the number is, we're just looking for positive or negative. And then if I put 2 in here, I'll still get a positive. So that product is a positive. The only sign change occurs at once, so this would be the only point of inflection. This is not because it doesn't have that sign change going on. So C is your answer.